No question, we're going to look at the final part. The final part is actually saying that now there is friction. Now there is friction. So repeat part A or part A some more, no, not referring to part B. It's referring to part A. Part A means they are crossing the equilibrium position. Okay, equilibrium position. But this time there is friction. The floor is roughed. So again, I draw two diagrams to illustrate the two position, the initial position of the block and the final position of the block. Initial position, the block is the same as the part A lah, or part B also, they are the same. Okay, so initial position means the initial position is 0.05. Stretch it 0.05 and stop there. Your hand, don't release it yet, and stop there and analyze the situation. The situation is kinetic energy 0, gravitational potential energy 0, spring potential energy, we use the formula, right? So this is the initial position. Then final position. Final position is here, equilibrium point, at the equilibrium point. So at the equilibrium point, kinetic energy is not 0, gravitational potential energy 0, spring potential energy also 0, because it's at the equilibrium point. But in this case, there is this guy here, 4 FD. Now this FD, the frictional force, is opposing the coming block, pulling back or pulled back by the spring. So as your spring pull back the block, it is rubbed against the friction along the surface of the floor. So that's why we have this FD opposing it. I draw it using the blue arrow. Okay, so now we are going to use the energy equation plus the work energy theorem. This work energy theorem. Energy equation, okay, and this energy equation, but at the final position, you have to record down how much work is done against friction. Okay, right. So we start. This one same as the all these are same, because they come from the same initial position. So kinetic energy is 0. Sorry, not this one. Kinetic energy 0, potential energy, gravitational potential energy 0, spring potential energy half kx squared. Then finally, kinetic energy half mv squared, spring and gravitational potential energy 0, work done against friction not 0, right? So gravitational potential energy I write over here, not gravitational, the spring potential energy half kx squared. Now this FD move over to the other side, minus FD, and that will be the kinetic energy. So half mv squared equals to half kx squared minus FD. Okay, so I copy again this equation on at the bottom there. But this time the FD, the friction, the kinetic friction is mu n. Mu is the coefficient of friction, n is the normal reaction, mg. D is the distance traveled. Now this distance traveled is this one, is this one. From the initial position until 0, it is 0.05. It's 0.05, the distance traveled against friction. Okay, the distance traveled against friction is actually 0.05. So elastic potential energy in the spring, K is 400, extension 0.05, coefficient of friction 0.15, the mass 5 kg, acceleration due to gravity 9.8, and how much it has traveled along the surface of the floor 0.05. Taking the square root of these numbers, we have V equals to 0.23 meters. Any question?
No question, sir.
No question. No question. Then what we have done here is we try to equate the total energy at the initial position and the total energy at the final position. But this time, you also include the energy used to overcome friction, the work done against friction. This one. Right? Next one. Wow, so many. Oh, this one again is the same. Okay, okay. This one same as the earlier one. Next. This one is slightly different. Okay, never mind. I I explained this one, the theoretical question, and this one is the same. They use the same energy equation. So and also the work done. So you go through this yourself. I do this, right? This one. This is different, and it is more related to you because it involves jumping, right? We jump from the springboard. Okay, so I will go through this with you. Now, before that, you read this question 5.9.
In the case of friction, what percent of the mechanical energy was lost by the time the mass first reached the equilibrium point? Hint, use the answer to part A and C.
Okay, so part A and part C, right? Let me explain what is part A and part C, right? Now, part A, okay, part A is this one, from the initial position until the equilibrium position without friction. Part B is still the same, from the initial position until the equilibrium position. But this time, it has friction, right? It has friction. So I'm going to compare the energy here and the energy here to find out what percentage of the energy is used to overcome the friction. Okay. The first part, how much energy I have. Okay. The amount of energy that I have is actually how much energy is stored inside the spring, half kx squared. So half k is 400, x is 0.05. So when I multiply these numbers together, answer is 0.5 joule. 0.5 joule. So this is the total amount of energy I have at the initial position. At the initial position here. Right? At the initial position here. Stretch the spring, stop there. How much energy I have here? Half kx squared. This is it, half kx squared. The total energy that I have. Then I also want to find how much is the energy lost through friction. Energy lost through friction is Fd, the work done against friction. How much is F mu n? Mu is 1.5, n is mg. This is actually mg. This is actually, no, sorry, not this one. This is mg, right? This is the m. This 9.8 is the g. So this is the normal reaction. Okay, so the loss in energy is the frictional force multiplied with the distance moved, 0.15 mg distance moved. So when you calculate all this, the total energy is 0.3675 Newton. Okay, so this is the total energy that I have, 0.5 joule, not Newton, sorry, joule. Ugh, very careless. Okay, so this is the loss of energy through friction. This is the loss of energy through friction. This is the initial energy I have. So they ask you how much is the percentage. So I use this number divided by the total, multiply with 100. That will be the percentage used to overcome friction. Okay, so energy loss divided by total energy multiplied by 100. Answer is 73.5%. So a lot, huh? 73% is lost as friction, work done against friction.